Alright, today we're going to talk about a concept called handle stealing. And what it does is basically imagine we have this scenario right here. We have vidHandleSteal.exe, and this one has a handle to secret.txt with no sharing access rights. So it opens up a handle to the secret, and once it does, we cannot open up secret.txt anymore. Now, what we can do is we can, from our process, open up this process, duplicate the handle that it has to this secret.txt, which it keeps open, and then we can just use its handle right here to modify or read the file. Sometimes processes do this with no sharing access rights to like lock files, which, as we can see, is not pretty effective. We're going to showcase this in a moment. But also, sometimes we can use this for when looking for privilege escalation vulnerabilities in third-party software. And the scenario is as follows. We have a process which has high privileges. H for high integrity, and this is the P process. We have the file over here. Bam. And the parent has a handle or a key. Remember, handles are like keys to processes with different access rights. Okay, and this handle is a special handle because it is inheritable. Is marked as inheritable. Now, if a process with high integrity has inheritable handles and then spawns a child process, like a process underneath that parent, a little C right here, and this one is medium integrity, this medium integrity process gets the handle as well. Because we would not be able to just access the parent process, right? Because it's higher integrity. Now, once it spawns with this inheritable handle, we can go in, open up the process, and get the handle. And this is us, and we are also medium integrity. And now we have the handle in our hand. And with that handle, or with that key, we can go boom, and access the file. Even though it may be locked by the parent process, or even though it might be not accessible because we need higher privileges to open up a handle to this file. But because a higher privilege process has already opened up a handle to this file, which they often do to make lower privilege processes from the same program be able to modify and interact with files on the disk, which are basically locked because the processes don't have the correct privileges. That's why they spawn them as child processes with inheritable handles, essentially. And if you can spot that, boom, that's jackpot, because you can just clone the handle and bam, get access to the same file. All right. Let's not save this, and let's make this big. Okay. Now, as you can see, we have this code right here, which is the locking mechanism. And if I just go ahead and compile that, I think it's already compiled. Let me just say source repose. Yeah, okay. Okay, vidHandleSteal. Right. x64 debug. Okay. All right, here we go. We have vid handle steel.exe. Let's just run that. Vid handle steel.exe. Or actually, can we open up cmd.exe right here? Okay, it just does it like that. Yeah, so let's open up vid handle steel.exe. As we can see, I use create file to open it. Here's the handle that we're going to duplicate. This is the process ID of the same process because we're going to take that as an argument. You can do that without knowing the process ID and just take a snapshot of the whole OS and just loop through every single process and see which process you actually need. And we're holding up open this handle because if we were to close that handle, we are not going to be able to duplicate it, right? Actually, I shouldn't have made that big because, all right, we need another command prompt to then run our program. And I'm going to copy and paste a few things in the code of ours, but I'm also going to write a bunch of things like per hand because I do not want to present the code to you just like that for you to copy and paste it without actually understanding what it does, right? So how do we even get, or how do we do this, right? How do we copy handles from another process? Well, first of all, we need to open up that process. Then we need to use a, use a function from NTDLL, which is undocumented, but it's documented on the NTDoc called Entity Query System Information. We need to use that. And then we can use Entity Query System Information to get the handles inside of that process. And then we loop through each handle and look at if that handle is actually a handle to what we want, right? Now, you could even, for enumeration purposes, if you just look at binaries that are the same privilege as yours, which are running in an app that you're looking at, you can just open up the binary itself and then just loop through every handle and look at what it accesses and then just print out every single handle. So that way you can basically find out if there even is a handle that you want or need to duplicate. Right, so first of all, we need to include a few libraries. We need to include windows.h, and we need stdio.h. Now we're going to have to define a few things, which if you don't know where to find those definitions, you can just watch my video about the NT API. I think it's called like bypassing Windows Defender. It's part of the Making Rootkit series, which by the way, we're going to continue. Don't worry about that. I've got a few questions about when there's going to be a new video about that. But making a rootkit is pretty, time consuming and time intensive. So preparing a video about it takes some time. In the meantime, we have stuff like this, right? So these are the NT API objects and the NT API function that we need to predefine to have the function shell where we can then put the original NT API function into by getting a module to NTDLL and doing get proc address. Always forget the function names. Now, All right. And then we also have, what am I doing? Oh, okay. Then we also have the NT statuses, which we are going to check because they get returned by the NT query system information. They get returned, and if it's a stato info length mismatch. So basically how this function works is we provide it with a buffer for it to write into the output. And if that buffer is too small, we get a status info length mismatch, which is this value right here. And if that's the case, we're just going to increase the buffer size, and then we're going to try again. And we're going to do that until we either get like a weird error or until, you know, we actually get all of the output. Then we have NT success, which, you know, just indicates that the function returned successfully. Like I said, I have made a full video about where to find these definitions and how to do NT API stuff. Go watch that video. So let's create our main function. Int argc and char double pointer argv. So somehow my camera died again. I don't think we're at 10 minutes yet, but whatever. So we're going to check for the length of arguments, or how many arguments are there, because the first argument is going to be the process name itself, and the second one is going to be the first argument provided to the process. Like if we open up vithandlesteel.exe, this is the first argument right here, the process name itself. And then if we were to pass arguments, that would be the second one. So if that's smaller than 2, if that's smaller than 2, then we can conclude from that we only opened the process, we didn't provide any arguments. So if that's the case, we're just going to do a printf. We're going to say usage, get a string from that, and target PID, which the string is going to be argv0. So now it would say, okay, hey, how you actually use this program is our program and then the target PID. Bam. Oh, then we obviously have to return. Cannot continue after that. Can actually just test that out real quick. Actually go right here. And as you can see, we have usage, you know, just debug information. All right. Now we need the target process ID, which is going to be a D word of the argv1 of the first argument, right? Because we're going to supply the process ID. Then we need to open up a handle to that process equals create file. So we do create file, and then actually to kind of like prove that we cannot access secret.txt, we're going to first try and open up secret.txt. So we're going to do handle secret is equal to create file. And also you would use create file for only files, right? The other one would have been create process. No, with an open process. Fucking hell. Create file secrets.txt, and we can use a dynamic path because it's in the same path as our exe file. We want generic read. Is that? Okay, that seems fine. File share read. Cannot really see because of my microphone. Security attributes, we can leave that as null, I think. Creation, I think that was open existing. Flags can be 0 and the template file can also be null. So I'm going to check if that worked. If secret is equal to invalid handle value, I'm going to print f actually we're going to do some fancy stuff. Ooh, damn. Boom. Hey, you cannot access that file. Bam. And then I'm going to also do a get last error, which going to include a new line and then get last error like this. Okay, and then we're going to return, right? Return 1. We compile that again. Seem to have worked. And do this. Boom. All right, we need the target PID, which we got right here. 6880. And we got, hey, you cannot access that file, right? Because we cannot open up a handle to that file. Because the other binary said, don't let anyone access that file. Okay. Oh yeah, that's my fault. And then to do error, something like this, and then error 32 is going to be an access violation, which it should be. Do this again. Yeah, here we go. Actually, going to remove that so it's nice and clean. All right, so now let's see what's next. Right, now we need to get the anti-query system information function into our shell that we made, which I'm just going to copy and paste here because I've done that before in another project. Right. Is that address and then right, okay. Boom and boom. So this is how you use the anti-query system information, which is basically you open up a module to NTDLL and then you get NT-Crew system information by using getProc address, and then debugging stuff, and then you call it with system extended handle information, which basically gets every handle, and you give it the buffer, and then you, like I said, increase the buffer if we have a size mismatch. And if it worked, it worked, right? Right, these are still part of that. Right, we have the stolen handle and the found handle, or we have the, whatever. It's pretty self-explanatory. Fucking hell, man, I cannot speak today. Okay, so now we can open up the process, which we're going to try and steal the handle from. So we're gonna handle open process, I think. Seems to be fine, right? Access rights is, I think, the first one. Open is not open process. Process dupe handle. Or did I just do something else? No. Open process is correct. False, and target PID, because that's the process we want to open, right? Now, why is that? Oh. Yeah, my dumbass, right? And is that not? Was it target PID? Didn't we? I'm pretty sure we defined it above. Pretty sure. Target PID. Here it is. There we go. Okay. Yeah. If that worked, or if that didn't work, hproc, I'm going to say printf, going to do the fancy minus again. Hey, you cannot open that process. And we're going to also error send you with get last error. Get last error. And we're going to return 1. So this next part is also, well, it's not really complicated, but I'm still gonna copy and paste it because we still have a long way to go. So the camera died again. But essentially I'm going to copy and paste just the rest of the code because I really can't be asked. I've got other shit to do as well. Sorry guys. Sorry dude. It's just, I've got other shit to do than record, right? Why is all of that not working? Yes, it is, bro. Target PID is right here, bro. Am I like retarded or do I not? Oh, I said Trajan's. That's why. Okay. Yeah. Little typo. There we go. That should fix pretty much everything. And right here I used another function, which was just a wrapper function for get final path by handle, which we can also just define up here, or rather not inside of the main function, right? Boom. Which this basically just looks up the file name by the handle, right? So we can open up secret.txt. Okay, so what I just copy pasted is basically we're walking the handles that, or like we're looping through each handle inside of that target, and we just look at it and see if it points to secret.txt. So we're going to do fucking hell, bro. We're doing a for loop, right, for each number of the handles, and then we try to duplicate that handle. So we're duplicating every single handle, and then we're looking for secret.txt on that handle, on that duplicated handle. And if there is a handle with secret.txt, like we compare it right here, then we say, okay, we found it, and then we break out of the loop. And then we have, you know, because we found it, we already duplicated it, so we duplicated it, right? And then as a final touch, we read what's inside of secret.txt. Pretty straightforward, not too hard, right? You need to be kind of familiar with anti-query system information or just anti-API stuff in general. And this is a thinking too much. But, you know, if you watch my other video on that, that shouldn't be really a problem. And if you try and do stuff like that as well, then that also shouldn't be a problem. So let's save this and compile this. Now we can again do video.exe on 6880 on that, you know, process that has the handle open. And all right, we return immediately after trying to access the file. That's my fault. Obviously, we're not supposed to do that, right? Where is it? Right here. Because if you immediately return, like this is expected to happen, right? If you immediately return, we don't even trigger the rest of the code. Okay, wait, let me just see this beforehand. Boom, you can now access that file, perfect. We found the file handle in here, which points to secret.txt. We duplicated that handle, file content via stolen handle, and this is what's in that file. And if we close this and open that file in Explorer real quick, we can see that is actually the content. Boom. Yay, right? So usually you wouldn't really do that with text files, or at least that's not my experience, unless you're like working with log files and doing like log rotate stuff. But if you find an application that like accesses a DLL with the concept that I already explained, with the parent process having a handle to that DLL and stuff, with some like on the ExpressVPN I showed you last time, the ExpressVPN updater, it uses a library called Costura, which does basically for which basically lets you include the DLLs it needs inside of the binary and then unpacks them at runtime. So this would be a good edge case to look for, okay, is there any handle that is being opened to a DLL to like write to it or to read from it, and then is that handle inheritable? Does it spawn a child process? And generally just look at every single child process of a privileged process and just look at what handles it has. And sometimes there's some interesting stuff for that, right? Sometimes it has some interesting handles, which you can do some interesting stuff with. That's basically the lesson of this video. Yeah, I hope you liked it. I hope you learned something. Yeah, I mean, that's it. Yay!